Have you noticed that there are lots of kinds of numbers? Like, for example, 1, that's a simple number. But have you noticed those numbers that are very complex to understand? For example, we have 2.5 times 10 to the power of 33. And we also have decimal point, like for example, 0.00287. And the question is, what does these numbers indicate? For example, if we're going to relate it in real life situation, in a container, we all know that that container is full of atoms. So what are those atoms? Those are the small unit atoms, the small part of particles. But these atoms cannot be seen by our naked eye. So that's why we cannot state the accuracy or the precise number of a particular atom in a container. That's why we use a significant figure to measure the estimate number of particular substances. There are rules of significant figures. Number 1 rule is all non-zeros are significant. For example, 1, 2, 3, 4, 5, 6, and so forth. Rule number 2, zeros in between other digits. For example, 6.003. So the number of significant figures is 4. Why? Because the rule says that there is 0 between the other digits. So for example, zeros other number than zeros, for example 6 and 3. So the between them is 2 zeros, so that could be significant number. Rule number 3, leading zeros are not significant. For example, 0.00035. So the only significant there is 2 significant figures, only the 3 and 5. Because the rule says, again, that leading zeros is not significant. Trailing decimals numbers are significant. For example, 0.03500. So that means that there are only 5 significant figures in the numbers. Because the leading zeros are not included, as I have said in number 3, the rules of number 3, but the rules number 4 is the trailing decimals numbers are included. For example, there are leading non-zeros like 3 and 5, and then the following are 3 zeros. So that could be included. So that would result to 5 significant figures. So when adding and subtracting, use the fewest decimal point. So for example, when you're going to add some decimal point, you need to evaluate the fewest or the least decimal that has been added in the numbers. For example, in multiplying and dividing, it's the same thing. You need to follow the rules. The rules is to look for the fewest decimal point. So if you're going to multiply or to divide the decimal, you're going to evaluate those numbers that have least or fewest decimal point. And in order for that, you need to crush out or cancel out those numbers that are not included in the answer. So in the last part is the rounding off or the rounding back. So we all know that since we have it in high school and elementary that if the last digit is 5, we're going to round it up. However, there also we call it arcane rulings in the rounding off of the numbers. For example, 26.5, it doesn't mean that it could be 27, but it could be 26 only. Another thing is 275, and it can be 228. So in arcane rulings, so it depends upon the following numbers. So if it is even, then you need to round it off, and if it's odd, you're going to round it up. So it's 50% not particularly sure that you're going to round up the numbers, but also 50% that you're going to round it off